we will now use the decreasing returns to scale. Suppose there are two firms, firm 1 and firm 2, and the market demand function is this, cost function of firm is same, it is this, both the firms, and firm competes in terms of price, that is Bertrand competition, and the consumer buys from the firm charging lowest price, and if the price is same, the market is equally shared between the two firms. So, find the pure strategy Nash equilibrium. We have to solve the pure strategy. So, here again we get the profit of firm 1 is this if P1 is less than P2, and it is equal to if P1 is equal to P2, and it is equal to 0 if P1 is greater than P2. We get this. So, we find out P such that profit this is equal to 0. We get this at two prices. So, we get this is equal to 0. So, at P1 is equal to 10 and P1 is equal to 20 by 3, we get this. Again we find out that this when this is equal to 0. So, this is equal to 0. So, we get when P is equal to this and P is equal to P is equal to 5, we get this P1. So, these prices are going to be same for firm 1 and firm 2, and we get another price when this is equal to this. So, this implies this. So, it is (30 by 4). Now, if we plot this function, this function is this point is 10, this point is d by 3. this function is it's this point is 5 and this is 10, this point is it's 30 by 4. Okay. So, and here we are doing profit. So, we will get the same prices for farm 1 and farm 2, and here we know that this range, because if farm 1 sets a price suppose here, farm 2 if it undercuts it will get this, but if it set the same price it is going to get this. So, if we look at this whole range of prices, the Nash equilibrium lies in this range. So, each price in this range constitute a Nash equilibrium, and P1 is always equal to P2 and they lie within this range. Okay. Let us solve some problem on Stackelberg competition. So, in this problem, suppose there are two farms 1 and 2 producing differentiated product. Farm 1 produces good 1 and farm 2 produces good 2, and a market demand function is this, okay, where P1 is the price of good 1, P2 is the price of good 2 and Q1 is the quantity demanded of good 1 which is produced by farm 1, and market demand function for good 2 is this 10 P2 minus 0.5 P1 equal to. So, here Q2 is the quantity of good 2 which is produced by farm 2, and the cost function for both the farms are same and it is given by CQ. Okay. Suppose farm 1 moves first and farm 2 moves second. So, it is a sequential game and that is why it is a Stackelberg, and farms competes in terms of quantity. So, this is again a Stackelberg quantity competition with differentiated product, and we have to find the subgame perfect Nash equilibrium. So, from this first what we will do, we have to convert this demand equation. So, this you can write simply because the demand for good 2 is this, right. So, from here you can write this, substitute here, instead this you take this here, we will get Q2 and this you can write it as Q1. So, this is 5 Q2 which we can write in this. So, this is the inverse demand function of good 1. This. Similarly, since the demand functions are more or less same, inverse demand function for good 2 we can write Q1 0.75 equal to P1 equal to P2. This is the price of good 2. So, from this we can write the profit function of farm 1. profit function of firm 1 is 5 minus Q1 0.5 Q2 Q1, cost is C, marginal cost is constant C, and it is Q1 divided by, this is the profit function of firm 1, and profit function of firm 2 is it is this. Now, here this moves first and this moves second. Okay. So, we will use backward induction to solve this problem, right. So, suppose Q1 is the output in stage 1, then we will find the reaction function of firm 2. It is this minus C, which is equal to 0, which is the first order condition. So, from this the reaction function of firm 2 is 5 minus this is the reaction function of firm 2. So, given any output of firm 1 in stage 1, how much output firm 2 is going to produce? It is based on this. This is the reaction function of firm 2. So, now what do? We plug in this in the profit function. Just wait a minute, this is okay, this should be plus. I have made a mistake. See, this is plus, so this is plus. Okay. So, it will be plus here, it will be plus here. So, here it will be plus here, it will be plus here, plus here. So, this reaction function is actually Q1, Q2. This is, if Q1 is equal to 0, it is taking a positive value. This Q2 is taking a positive value. It is something like this. Okay. This point is, you can say, this. Okay. Now, let us substitute this here, and this is going to be, so we are substituting here. So, it is this 0.5 . it is this, which we can write as 12.5 . This is 1.75 Q1. We are getting this. Now, we take this with respect to Q1 and we will get so first order condition will make it 0. So, we get the output of firm this must be okay. So, it will be 2. So, it is 2.373. So, Q1 is this, and we plug in this Q1 in the reaction function. Reaction function is 5 minus this 0.75 C plus 0.5 Q1, this is Q2. So, plug in this is going to be the heat. So, we have this is the subimperfect Nash equilibrium in this case. Okay. So, Q1 is this and Q2 is this. By plugging in the reaction function, the value of Q1, we will get the Q2. Okay. So, we are going to solve this second problem, and this is actually an extension of the first problem. So, in the first problem, we have got the profit function of firm 1 of this nature, this, and the profit function of firm 2 this. So, here we will find the Cournot reaction function from this profit function. So, if we take this, we will get in first order condition is going to give us so this is the reaction function of firm 1 given output of firm 2 Q2. What is the optimal output of firm 1? This. Now, we find out the reaction function of firm 2. Yes. And first order condition is going to imply yes. So, this is the reaction function of form 2. So, given any output of form 1 Q1, what is the optimal output of form 2 Q2? We have got this. So, if we plot them, this is Q1, this is Q2. This function, if suppose Q2 is 0, then this is going to take a positive value. So, it is something like this, and this point is this, and this, if Q1 takes a value 0, it will be somewhere here, and slope is going to be less than this slope. So, this point is 50 minus, and this is the Cournot outcome. Right. Now, we will study the Stackelberg outcome based on these reaction functions. So, we know the profit function of form 1 is it is this. So, we will look at the isoprofit curve of this generated from this. Now, if you look at this here, consider this reaction function. So, here if we move in this way, output of form 2 is increasing, Q2 is increasing. Now, here if we keep on increasing Q2, keeping Q1 fixed, see the profit is increasing. So, here if we fix this, profit is increasing in this direction. So, profit increases in case of the form 1. And if we take the from total differentiation of the isoprofit function, we get yes, and here this portion will be simply so it will be this. So, this is going to be this. Now, here look, this portion is actually the reaction function of form 1. So, if we fix Q2 and if we keep on increasing Q1, here if we fix Q2 and keep on increasing Q1, this is going to take a negative value, it takes a 0 value when it is in this direction. So, it will be something like this. And if we keep on decreasing Q1, keeping Q2 fixed, then what is happening? This is going to take a negative value, this is going to take a positive value and this is negative. So, it is going to be a negative. So, it will be something like this, it will be like this. So, it is 0 at this point. So, these are the isoprofit of farm 1 and the Stackelberg outcome here, it is going to be some point here and it is given by this point S Q2S, because Stackelberg outcome is such that the isoprofit curve of farm 1 is going to be tangent to the reaction function of farm 2. This is the reaction function of farm 2 and this is the reaction function of farm 1. Yes. So, this is the Stackelberg. Now, we have to find out whether farm 2 is going to choose along with farm 1 in stage 1 or it is going to choose after farm 1 has chosen its output and that is in stage 2. So, we again find the isoprofit curve of farm 2. So, the profit function of farm 2 is this, and then here if we fix Q2 and keep on increasing Q1. If we fix Q2 here, Q2 here and keep on increasing the output of farm 1 Q1, then the profit of farm 2 increases and we got it from this here. So, it is same in this case also, in this direction profit increases. So, we get from total differentiation of isoprofit function of farm 2, we get this, which is equal to this. So, this is the reaction function of farm 2. So, when we are at the reaction function of farm 2, this takes 0. So, this is a 90 degree. So, isoprofit curves are like this, because if we keep fixed Q2 and keep on Q1, here it will be this will be negative, and if we keep fixed Q1 and keep on increasing Q2, this will be negative, and this is negative, so it will be positive. So, if we keep this fixed at the reaction function and then keep on decreasing this, then this is going to be positive. So, this is negative. So, that is why this portion is negative and this portion is positive. So, these are the isoprofit curves of form 2. Now, we derive the result. This is Q1, Q2, this is the reaction function of form 1, this is the this is the Cournot thing, and suppose this is the Stackelberg. And these are the isoprofit of form 2. So, if it moves simultaneously along with form 1, then this is the outcome, Cournot outcome. But if it moves second, then this is the outcome. So, profit here is more than the profit at this point. So, that is why form 2 moves second after observing the output of form 1. So, but in the homogeneous good case, we have found that form 2 will always try to move along with simultaneously along with form 1. But here in this case, we have found that form 2 is preferring to move second, that is in stage 2 after observing the output of form 1. So, here we have there is a second mover advantage.